This is the Tools and Technology Seminar Series. It's basically just a venue to talk about tools, technologies, methodologies, algorithms, whatever that sometimes they are in development, so it doesn't have to be a finished product. Other times they're, completed projects or different versions of projects or tools. And sometimes stuff that's been around for a long time that's just of interest to researchers. So today I'm pleased to present Chris Clark, who is a developer in the School of Public Health, I believe in biostatistics.
Yeah.
Very good. And there's a sign-in sheet. We're going to pass it around, so please sign it.
All right. Thanks, Marcy. Hi, everybody. My name is Chris Clark. I work in the School of Public Health. And today I'm going to be talking about LocusZoom.js. Has anybody here ever heard the term LocusZoom before? Okay, a couple people, yeah. Apparently, this is a thing that has existed well before I got here. I've been with the School of Public Health for a little over a year now. And I come from a development background, not a research background, so there's probably a heck of a lot more knowledge about the actual research that goes behind this stuff in this room than I have in my head, way more. So you guys could probably teach me a lot of things about that. But I'm going to do my best to talk about it. Also, at any point during the talk, I have this poster, because I'm just fresh coming back from ASHG, and this is a poster also talking about LocusZoom.js that we took out there. And a lot of the graphics on there are going to be present here in the talk, too. So that's the little supplementary thing. So in a nutshell, LocusZoom.js is visual interactive plotting of GWAS results. Well, what is that? First of all, let's back things up much further to what is the problem we're trying to solve. I know at least one familiar face here who has seen this before. I always like to throw this out as the 0th question of programming. At any point, if you're programming anything, because I'm a programmer, and this is how I think, this is the most important question to be asking. And if you're not asking this question, you're probably lost in the weeds or you're too focused on a solution. So what is the problem we're trying to solve? What are we even doing here? Well, my text got a little small, but okay. So the problem in general is interpreting GWAS signals requires context. Now, I overheard before we got started here that you guys have been doing this for a while, and it was only a couple weeks ago that somebody really started talking about what GWAS even was. So I'll do a quick overview of that as far as I know, which I'm no expert again. But GWAS stands for Genome-Wide Association Study. And basically what it is from a data standpoint is it's a whole lot of p-values, and those p-values are mapped to single variants throughout the genome. And those p-values obviously represent some kind of a signal for some effect that we're studying. Variant makes this happen, etc. And that requires context. There's so much context because genetic study is so complicated. I'm looking at this one variant. This maybe it's a single nucleotide polymorphism, so it's just like this A turns into a T, and I know that happens to happen at this exact spot in the genome, but maybe I also need to know what genes are present there. Maybe I need to know what histones are present there. Maybe I need to know how that variant is affected for other phenotypes that we've studied, which may have a completely different set of p-values. That context is important to understand why, if this p-value is high, what that actually means. And so context comes from arbitrarily many data sources, and arbitrary being the operative word here because, yes, you may have a reference panel that says what your genes are, but you may be pulling in data from all kinds of places. Maybe you're looking at how, protein pathways work in different cell types. I mean, there is literally an exponential amount of data that grows at an exponential rate over time, as there are so many groups like this one and my group, and then all the other schools around the world who are doing research on this stuff, and all the pharmaceutical industry. There is so much data, and it's all flooding out to the internet, and that is all useful context. How do you integrate it? That's tough. So combining all of that together is hard, and then navigating around that stuff is hard. That's what we're trying to solve with this. So it's a big ask. But the original approach started in 2010, and this is the LocusZoom that the few of you that raised your hands may be familiar with. So this is an R and Python package that is open source. When you download it, if you want to run it locally, you download it with that data. It comes packaged with it. And so on the lower end, that could be a download of 4.3 gigabytes, not small. On the high end, 10 gigabytes, which actually on the high end, if we're calling that a complete data set, that's pretty small. 10 gigabytes of data, considering that we're studying the human genome and all of the biological ways that the human genome can possibly do anything, 10 gigs is nothing. So that right there, our data is complete, but there's so much more data out there that we're not getting included. And finally, when we're running this on the command line, we're going to generate a static plot that gives us a visualization of our association signal in a region of the genome. And this is what it looks like. Got a little dark. That's too bad. But essentially, we have all of our p-values as little dots on a scatter plot. Here's our little association peak. You can see we have negative log 10 p-value over here. So this is a 10, which, you know, GWAS significance is usually around 8. Statistical significance is usually around 5. And so that's a signal that tells us something. Coloring is usually based on linkage disequilibrium, how often genes variants are passed down along with each other. And then for some context, we have some genes down here. So here is this particular variant cataloged by its RS number. And it happens to be inside this gene, and that tells us something interesting. And this is the kind of thing that would appear in a publication. This is currency for publishing results. So LocusZoom has been used quite a bit for publishing these kinds of things. In 2011, it was spun up into a web service where people could upload their full data sets. So you have to come to the table with your entire data set. You have to push that over the web, which right there is a limitation on just how much you can do with this data service, because you obviously can't upload a multiple terabyte data set. And again, you're generating static plots. So if your region looks good, but there might be something right over here, because as we know in studying genetics, you know, stuff that is neighboring usually has something to do with what you're studying. Not always, but it can, and it's important to look at that broader context. And if you're generating a static plot, well, you need to know what regions you want to look at up front. So when you upload your data, you have to specify, I want to look at this region, or I want to look at this set of regions. And specifying that region is not just I want to look right here, but I want to look right here, and I want to look at this scale. Maybe you're looking at a few kilobases. Maybe you're looking at a few megabases. If anyone here is not really familiar with looking at genetic data in terms of regions in the genome, you know, it's 3 billion base pairs long, and the analogy that I use is Google Maps. We've all used Google Maps, and you know, if I'm looking at a few kilobases, maybe I'm just looking at my neighborhood. If I'm looking at a few megabases, maybe I'm looking at my whole city, out to my whole country. And what I'm looking at those scales tells me different things. I can see different geographical elements, and I can learn different things about it. Same with the genome, especially when we're looking at association data that may have peaks that, you know, spider out really far across a whole chromosome, which is gigantic. So if you have to know your regions up front, and if you guess wrong, you simply won't see something that maybe you should be seeing. So enter the portal. The portal is this right here, which is the Type 2 Diabetes Genetics Portal. This was a grant that the School of Public Health, or my group, the Center for Statistical Genetics in the School of Public Health, got on along with a bunch of other folks, the Broad Institute out at MIT, big thing with the Accelerating Medicines Partnership, lots of 3-letter acronyms. And the goal with this, the problem these guys were trying to solve, is we want to build a web portal that will aggregate data for the study of type 2 diabetes. Specifically genetic data for the study of type 2 diabetes. And when they were putting this together, you know, they looked to our group and they said, all right, you guys have this tool LocusZoom, and this is really valuable. You know, we want to be able to see these local regional results across multiple GWAS studies. I mean, there are several dozen GWAS studies loaded in here, but the portal is built for arbitrarily many GWAS results data sets over time. And so they have whole teams of people at the Broad that are out there courting other institutions that have GWAS data saying, hey, bring your data into the portal. We want data for all kinds of different phenotypes and cell lines so that we can study all kinds of things, type 2 diabetes and related phenotypes. So lots of data that will continue to grow. This is a moving target. So they wanted LocusZoom in here. And if anyone here has worked with R to do some graphing, and anyone has worked on the web, there are some shims in there that can make you kind of do that, but really it's kind of like using a hammer to unscrew a screw. That doesn't really make a lot of sense. You just use a screwdriver. So the idea was, you know what, we need to rebuild LocusZoom for the web specifically, for interactive plots where people can actually start to navigate around these data sets and take a more exploratory approach where they don't have to know what they're looking for up front and they can discover maybe some interesting things. So that's the new approach starting in 2015, and thankfully that grant funding made them, oh, we got to hire some people for it, and that's where I came from. So the ideas here are we want something that is embeddable in a web application. Same problem that we're trying to solve with the original LocusZoom that I said in that earlier slide. Same problem, but now the method is different. So embeddable in a web application is important. Data streamed from APIs on request, that's also important. Because as we said originally with that problem we're trying to solve, is that context requires arbitrarily many data sets. That number of data sets can grow over time. The data sets themselves may be huge and they may be factored in different ways. And you know, we shouldn't have to load an entire GWAS data set to look at one region as if you're loading, say, the entire Google map down to neighborhood level when you're just looking at your neighborhood. That doesn't make sense, especially in a web context. So we need to request pieces of data and stream that and aggregate it together into a visualization. Heavy emphasis on interactivity, because again, maybe I don't know what kind of regions I want to look at. Maybe I want to just cruise around the genome a little bit and see what stuff is nearby and add different phenotypes, remove stuff, change things around. It needs to be interactive. And the primary focus is, of course, on the exploration of data. So static plots for publication is a nice to have, but no longer a requirement. Now we want something that is purely interactive. We're designing for pixels, not for print. So here's our interactive LocusZoom plot. This is actually supposed to be an animated GIF, and it's not animating, so that's okay. We're going to do, we got all kinds of live demos at the end of this presentation, so you'll see it in action here, because LocusZoom is functional right now and has been for some time and has been deployed to a few different places. But as you can see, it looks pretty much the same, right? We have our association data with all these, the scatter plot of different p-values with little peaks and stuff, and we have our genes, and that is our basic building block of context. And of course, there's much more data we can heap on top of that. So there we go. So development approach. This is just tools that we decided to go with. So primary language being JavaScript, the lingua franca of the web. Graphing library is D3. Has anyone here ever worked with D3 before? D3 is a fantastic graphing library in JavaScript. Everything that it does is in SVG, which is scalable vector graphics. It's actually a format that's been around for a long time. It's been around since the, I think the specs started getting written in the late 80s. So this is not a new format. But D3 is a very nice low-level graphing library. It's not the kind of graphing library that you will use to say, I want to make a scatter plot. I mean, you can. But D3 is much lower level than that, where you can essentially bind DOM elements in your page to data and do fancy things with that. Lots of interactivity. And then, of course, our environment is the web browser, which means HTML and CSS are also coming along for the ride. And go. There we go.
What does you mean image format is SVG? If it's an interactive plot and SVG is static image, how can we make it interactive?
So, good question. So the question was, if SVG is an image format, which it is, how do we make it interactive? Well, SVG, as an image format, it's not a binary image format. So JPEG, PNG, all these things, well, actually, PNG can go both ways, but JPEG, as an example, is a binary image format where your data is stored in pixels. In SVG, and here's an example, this being built in SVG is the actual data looks a lot like HTML. In fact, it's parsable by web browsers as HTML. It's in that markup language universe, so it also plays nice. You could also describe it as XML. XML is a superset of all these things, so SVG technically is also XML. And so what that means is it can be rendered out to pixels on a screen, and it can be rendered by most graphics programs that will work with vector formats. So, you know, Adobe Illustrator is a good example. I believe even PowerPoint will render SVG as well. But the way that it's actually stored is as text as tags. And so there's a tag that says this is a circle, and the circle is positioned here, and its color is red. And that's how that is rendered instead of individual pixels that make up that circle. And so as a result, SVG can be interactive when it's inside the browser because it's all built with DOM elements that you can attach JavaScript hooks to, and that you can use query selectors if you've ever used jQuery or anything like that, and you write the little string that says, select these. You can do that with individual elements inside the SVG. So it kind of works both ways. Does that answer your question, sort of?
So it's like an HTML.
You can think of SVG as HTML. They're very, very similar. But SVG is sort of a special set of tags that will be rendered by a browser that's also rendering HTML, but renders graphically, and thus can be made interactive or can be exported to another format as a static image. So here's an example of what we're going to build. I was just going to kind of step through the architecture, the architectural approach to making a LocusZoom plot real quick, and then we'll dive into some live demos so you can actually see how it works. And by the way, if you guys have any questions at any point, feel free to just shoot them out. So here's the actual SVG architecture. And it's still a little dim, but taking this same view, we have this thing up here. Let's call this a panel, and let's call this a panel. So this is a panel of association data. This is a panel of gene data. And then within a panel, we want to do some layering, because if you look closely here, we have this little line, this line here. That's actually recombination rate information, which I probably will give you a wrong definition of what recombination rate is. All you need to know is it's data that can be represented as a noisy line graph, and it's important. It's important to see in context because it's still data that we're able to see in regional context. And here we're looking at chromosome 8 between, it's addressing on the x-axis. It's like a one-dimensional address. We're going across that 3 billion base pairs, and we're looking at a very specific, 19.7 million, the 19.7 millionth base pair to the 20.1 millionth base pair on chromosome 8. That's what we're looking at right here. And recombination rate is just some data that is very important when we're looking at graphs like this. And so we want to show that too. So, it's important to show these superimposed on top of each other. So we have panels, and then within panels, we have data layers, we're going to call them, and those are kind of stacked z-index on top of each other. And that's what we get here. If you can kind of, wrap your mind around the 3D explosion here. Here's our gene tracks panel, and then here's our association panel with our 2 layers. And so our panels go Y down the page, and our data layers go Z into the page. And that gives us a lot of flexibility for showing a lot of data. By the way, LocusZoom is built with abstraction in mind. We don't know what all data we're going to want to look at and potentially display. And we want the ability to spin up new data layers for looking at new data as it gets discovered, as it gets aggregated. So LocusZoom is really a platform for doing that. 2 big pieces need to come into play to actually make a LocusZoom plot work. One is data sources. Data sources are JavaScript functions that tell LocusZoom where the data is coming from. And we designed some things, some namespacing, so that you can pull data from arbitrarily many places, and they can have collisions. Most data that we're looking at is going to be data that you could make CSV, just kind of column-based data, where here are my column names, and then here's a bunch of rows of data. Sometimes the data might be a little bit more like a JSON object with a lot of structure to it. We want to support all of that. And sometimes, say, 2 endpoints might have the same data or very similar looking data with similar column names and everything. We want to make sure those don't collide. So there's some namespacing that goes on here. There's a lot of built-in functions for pulling down data in sort of predicted formats. But the whole thing is designed, and there's extensive documentation for how to do this, so you can design your own data source. If you have your own endpoint that's able to serve data, you can write your own JavaScript function, make it go. It's all client-side, so even if it wasn't open source, it effectively is, and anybody can hack the hell out of this thing and make it work for them. The other key element is a layout object. A layout object is a big JSON object that describes how the plot actually looks, all the way down to basic stuff like your dimensions, your width, and your height, down into, here's my data layers, and I want this to be a scatter type data layer, I want that to be a line type data layer, and add some colors and this and that. Interactivity is defined in your layout, but the nice thing about layouts is they are JSON objects, true JSON, which means they are serializable and portable. And that was a big thing because we wanted LocusZoom to create these shareable plots where here I am and I want to share my data with somebody in Germany and I want him to be able to drop LocusZoom directly in place on his own web app, drop the same layout in place, see exactly what I see. And then we can collaborate on results and just do science. And so the last step is, of course, just one line to put it all together. And so we call populate. We give it one of those DOM query strings that says fill it in this element, and then we get an interactive plot. It's just that simple.
Question.
Yes.
So looks like you build in our descriptive config for the graph during that layout, and you sort of inventing some kind of a grammar that has these types, and you know what kind of marks you're gonna put on your SVG. Do you guys consider using like a Vega or Vega Lite for that? They're like pretty widely used grammar specifications to build D3 parsable graphs that you can. Same idea, but there is already like well-established grammar for that.
That's pretty new to me. So Vega is what it's called?
Yeah.
I'm not familiar with that. I'm going to have to take a look at that.
It comes out from the same lab that did the D3.
Okay.
The Stanford visualization. Now they moved to University of Washington. So they developed this big grammar that predefines plots, the descriptions of the plots that are parsable by D3. So you just need to define exactly. You need to define your type. You need to define like how many variables you have. They have layering. They have the interactivity. You can actually say on events, on mouse over, on mouse leave. So that stuff.
I'm gonna have to look into that.
It looks very similar to what you are doing in your layout settings.
Yeah, there have definitely been a few places because we're building this for it's a trade-off, especially as a developer. Trying to build something that is heavily abstracted to do just about anything to something that's a little more purpose-built, narrowing that focus a little bit and making it work for regional genetic association studies. And so there are a few places where, taking a standard that D3 has built in, we had to sort of deviate from that path a little bit and be like, this doesn't exactly fit our use case. Really good example is D3 has some syntactic sugar for creating zooming. And zooming is a very important piece of LocusZoom. And I'm going to pull it up. I mean, it's right there in the name, LocusZoom, right? And so we wanted zoom events that could be, hooked to the mouse wheel or whatever. And we only want zooming on the x-axis, and we want that to trigger events to do redrawing, just based on what regions need to be filled in. And the stock D3 zooming, we actually kind of had to reverse engineer it and develop our own because there was simply no way we could make it work. It was trying to do too much. So, but that is interesting. I'm going to look at Vega, and yeah, I mean, we want to make this as standards compliant as possible. We want to make it as use as many existing frameworks that already have a large base of users and developers and documentation. So that's that much less documentation we have to write. But unfortunately, we can't do that everywhere. So cool. So yeah, that's the big confusing graph that shows how LocusZoom gets set up. So one more thing is, and I've talked about this a little bit, everything is customizable, or in theory it is. So, this just shows a little preview of syntax for, hey, I have data in some weird new format, and it's data that has never been shown on a regional association plot before, but I can think of a way that it belongs in there. We've provided some API hooks so that it is, in theory, practical and straightforward to build your own data source for your specific special Snowflake data. Likewise, for rendering that data, all the way down to interactivity. Building out new custom data layers is also something we've provided a lot of API hooks for, where things are abstracted, and ideally you can develop a lot of custom things, especially if you know some JavaScript and especially if you know some D3. You can sort of utilize a bunch of the framework that's already there in LocusZoom to sort of get that much further, that much faster. Start with what we've already built and take it even further. So it is open source, hosted on GitHub, github.com/LocusZoom. MIT license. We wanted to go for the most liberal one we could find. We have comprehensive documentation that we're trying to update all the time, and we also have a CDN for it. All that stuff is up there. So now,
is the MIT license because Broad is involved, or because it's easier to deal with them as our own OTT here?
So the MIT license, I actually selected that license personally because I asked my group from the very beginning. I said, I want this open source right from the get-go. Do you guys have a preference on license? And they said no. So I got to choose, and I chose MIT because MIT is, in my opinion, one of the most liberal licenses. That it covers commercial use and everything. It's much more liberal than a typical copyleft type license.
Think of it more as a model for a license. You're not licensing for anything from MIT. Different organizations have made licenses under what circumstances you may use code. Can you redistribute it? All those kind of things. It's just a model for a license.
Yeah, and we could really go down the rabbit hole on open source licenses because there are so many different ones, and different ones have different levels of what you can and can't do, and what kind of restrictions they put on you if you're going to use this code in something else. And MIT, I just chose, which even if you go look up and read some of the thoughts on MIT, it's even kind of a misnomer, and MIT doesn't even want it called MIT anymore because they have so many different licenses in play. But that particular license is particularly liberal, where anybody can take LocusZoom.js and spin it up in a commercial product. Fine, go for it. I mean, we want you to do that. Really, all the MIT license says is give us attribution if you do that. And I believe, so that's the main website, LocusZoom.org, if you want to play with it, which I'm actually going to bring up right now so we can start checking things out. And yeah, some live demos. Yeah.
So, haven't seen from your presentation, how do you guys deal with interactivity? How do you deal with binding back and forth between user actions and your data model that you have?
Ooh, that's a big question. Let me see if I can answer that in the course of the live demos.
Okay.
And I'd be happy to pull up some code samples as well. Okay. So, everybody see that okay? Great. So the main LocusZoom website, it's important, at least we decided it was very important to preserve the original LocusZoom because LocusZoom.js is not a replacement for the original LocusZoom. It is, another solution to the same problem, but also some other problems in that space. Basically, making it web-based and everything. For so many people still rely on the original LocusZoom. There is really these things are meant to complement each other, not to replace. So we still have all the original stuff there, where you can get your single plots and you have to know where you want to look. We have our one interactive plot here. So right now we only have it where it's data that we have available for you because the new LocusZoom.js is really designed for hitting an API where I'm going to request, data from this data set in this region, give me just that back. And there are ways to make it work on data that people upload, but that's still very much a work in progress because taking a giant data set and turning it into an API is not a trivial task. So this is only showing some selected published GWAS results that we have loaded in a database on our backend with a web server front end to serve that as an API. So let's just choose any old one. It doesn't matter. First one there. And here is our LocusZoom plot. This is what the panning and zooming looks like, of course. Pan around, more data comes in. You can see we're just going to different parts of the chromosome there. Zooming with the mouse wheel, we can zoom out a little bit, we can zoom in. And that's that's the basics of the interactivity, but there's also a lot of other pieces that have been folded in that I haven't really talked about yet. For instance, tooltips on data, like looking at this gene here, we're pulling gene constraint information from exac, which was a request by the Broad folks. They wanted to see gene constraint data. I'll scroll that up so folks can see. So they stood up an API on exac where they're able to, we make a request with a bunch of gene names, and they give us back all of the extra, the constraint data for those genes. So every time LocusZoom, this version of LocusZoom, the way it's configured, every time we load a region, we have, I don't know how many genes there are here, a dozen or so, probably a little more than a dozen. But we create, just as an example, under the hood, it's going to create a single request to exac saying, hey, I want the constraint information for these genes, and it streams that into the tooltips based on how the tooltip is defined inside that layout object, that big JSON object. There's a thing in there for the genes data layer that says, on every gene, let's create a tooltip. This is what we're going to put in it. We also had to define that data source that says, hey, go to exac to get constraint data. So that's an example of all that.
Does it change things based on zoom level at all? In other words, if you zoom way out on a chromosome, you're going to be importing an awful lot of elements.
Yes.
And trying to...
Yes. So this is a fun problem that we've only just started to scratch the surface of. Essentially right now, LocusZoom, what you can do is in the layout, you can define a bounds for the zoom level, a maximum and a minimum. And we had to do that because when we first dropped zooming into place, we realized, oh, I just have to, twiddle my mouse wheel a little bit, and suddenly I can crash everything because it's loading way too much data. So the trick there is, once you start zooming out far enough, then you start to get into questions of binning. We want to bin this data together and stream less data down, and that is a problem for the server side, not the client side, right? Unless, you could make it a client-side problem, but you'd have to get all that data down across the net first, which seems silly. Do it on the server and only push what's actually needed. So LocusZoom.js being a purely client-side library, it's kind of it gets into the territory of not my problem, which is not a satisfactory solution. So we're looking at how to do that on the back end just for the API we have running here, because what we'd really like to do. How many folks here have ever heard of a Manhattan plot? Anyone? Yeah. So for those of you who haven't, a Manhattan plot is basically, it looks a lot like this. It's sort of, a scatter plot showing association data, but you're looking at the entire genome, all 3 billion base pairs. And it's called a Manhattan plot because it's usually organized into chromosomes, of which there are, 21 plus, depending on if you're including the sex chromosomes. So you'll have these columns, essentially, of these scatter plot dots, and you'll see little peaks pop up in different places. And to go back to my Google Maps analogy, which I always come back to, we're zooming in and out here, looking at a very small region on chromosome 16. I want to be able to keep zooming out, get to the point where I'm looking at all of chromosome 16, and there's some effective binning because chromosome 16 has, I don't know how many million variants, but more than I would want to load and try and display as individual circles in my SVG. So I want to be able to seamlessly zoom out, start doing that binning, again on the server side, display that stuff, and then go all the way out to a Manhattan plot to where I'm looking at the whole genome. And effectively, you get that Google Maps type interface where you can zoom from planet Earth level down to your house. That's what we want. And obviously, it took Google a while to figure out how to do that really seamlessly. They have a lot of tiling algorithms and stuff. So, we have a lot of work to do on the server side to make that happen. But that is a goal for the coming year. And I could see potentially some open sourcing of some server-side companion libraries to help serve up association data with that binning stuff sort of built in out of box. Yeah, so let's see. We did, by the way, because export for publication was a nice to have depending on who you talk to and a must have depending on who you talk to, we did include that. So there is a little download image button. And I could go into excruciating detail on the difficulties of making SVG on the web export nicely into an SVG that looks good in in any sort of publication and convert it to another format. But LocusZoom does that. We did the hard work, and it does that, and it does look decent. So it can be used for publication stuff. So yeah, this is LocusZoom.org. I highly recommend you guys check it out and play with it. But let me show you some other examples. So the portal, Type 2 Diabetes portal, which is at type2diabetesgenetics.org, kind of a mouthful. But this is free to use. All you need is a Google account. So that that's the small barrier that they set up. But otherwise, it's completely free to use. So within that, I just pulled up TCF7L2 because that one has actually interesting Type 2 diabetes stuff. And here is LocusZoom in the portal. This is an older version of LocusZoom because it's the Broad folks who are integrating it. So there are always a few versions behind. But it has a lot of the same features you saw before. We have our tooltips showing us lots of information. One of the nice things here, and this sort of gets to the level of interactivity that we really wanted with LocusZoom. Panning and zooming is great, and that gives us some context, but there's a lot more we can do than just panning and zooming. So conditional analysis is a big one. Who here is familiar with conditional analysis in any form? Okay, so a few. So essentially what conditional analysis is we're looking at a model right here. There's a model that generates these p-values, and conditional analysis is let's add some more pieces to that model, see how the data changes. So the poor man's conditional analysis is just making something the LD reference. So to give a quick overview of LD real quick, LD being linkage disequilibrium, basically we have a reference variance, and we're going to say, we're going to color that one purple just so it's different, but then let's color all the other p-values based on how likely they are to be inherited as a variant along with our reference variant. So this red guy up here, he's very likely to be, if you have this variant, it's very likely you also have that variant. This dark blue guy over here, if you have this variant, it's not very likely that you're going to have that. You might have that, but it's not likely that this one and this one are going to come together when two people are reproducing. So the poor man's conditional analysis is you can change your LD reference variant. So we'll do that. All the colors change. And that's one very basic example of some interactivity, some custom interactivity through with just like, I think it was just like one line of JavaScript to make that go. Another example is, let's say we're doing actual proper conditioning on this variant. So what that means is we are going to add this variant to our model, which means this variant will no longer show up here, and all of the other p-values are going to be recalculated on the fly, and we're going to see all these things shift around. So go ahead and click that button, and they're probably all just going to drop off, is usually what happens. I've yet to find a really interesting conditional analysis, but the idea here is that, if you have two peaks, let's say, yeah, they all dropped off. But the idea here is that if you have two separate peaks and you condition on one, that one's going to disappear. Everything's going to shift around. If this peak stays there, it means that these are independent signals. However, if this peak also drops off, it means that those two are actually dependent signals, or probably the same signal. That's the use of conditional analysis, which is very useful from a research perspective. Now, that actual conditioning, the actual math that's happening there, that's happening on the back end with some very fancy stuff that some very smart people at the Broad built to do that on-the-fly conditioning. It's very, very cutting-edge type genetic research. So LocusZoom isn't actually doing that. But where there is simple arithmetic-based, analysis tools that can be done fully on the client side, we're very interested in adding those. A big one that I'm familiar with is credible sets, which is my understanding is, show me which variants are, sort of in a group based on some filters. And that's something that we will be implementing in LocusZoom in the next few months. So development is very active here. And there are a lot of opportunities. There's really, the sky's the limit on what we could potentially do with this thing. Also, it is worth noting that every LocusZoom example I've shown you so far has your basic association panel and your genes panel, but there's a lot more that can be done. You can have arbitrarily many panels with data layers. So here we can add another panel for body mass index. The LocusZoom website that I showed you originally also does the same thing. You can add arbitrarily many different studies, stack them up, and see how they compare. This is not a particularly interesting data set, but I invite you to check it out and play around and see if you can find some interesting stuff.
Quick question.
Yeah.
So, and maybe there's no biological reason to do this. I'm looking at the top plot, and you did the LD thing.
Yeah.
You selected one specific one, and then you got some others that were green or orange. Is there a way to say, show me the red, green, and orange, and filter out the rest of that? 'Cause I can't even see like what's down in there.
Oh, right. Yeah, it's kind of a mess. So if we want to see what's down in here, what I can do is I can grab one of my ticks and I can just kind of expand the range there to get a little more detail. So we did add a lot of capability for sort of playing with your data set.
But it's but it's an all or nothing. I can't say show me p-values above or below certain values.
So in the current version of LocusZoom, you could, but you'd have to program some custom stuff. In the version of LocusZoom that will probably be released within the next week, there will be a new feature that provides some API hooks to do that in one line of code. And that kind of gets back to that data filtering thing I was talking about. So, if I wanted to just identify all variants that had, a specific field with a value that is, that maps to some arbitrary number of tests. So, maybe I want to set a min and a max, or maybe I want to do strict equality testing. Anything. If I want to stack those up, that's something that we have currently in code review right now. So it's developed, it's mostly working, and it's a first pass at it. So as end users actually use it and give us feedback, hopefully we'll refine it, make it more powerful. But yes, good point. That is something that comes up a lot. And we want to solve the abstract problem where I want to filter my data and I don't know how I want to filter my data. Or I want to try some novel, interesting things. We just want to make it easy for you to do that.
Do you have keys on here anywhere? You've got different colors, but I don't know what they mean.
Yeah, so this version of LocusZoom is pre-Dynamic Legend. And Dynamic Legend was added, I want to say, about a month ago. So here's our little Dynamic Legend there. And so there's a whole documented set of, getting back to that grammar and the layout, where you can define in a relatively short amount of lines in that JSON object how I want my legend to appear, including making it automated based off of the data that I'm getting back in different ways, which it's hard to automate based off of everything because a legend can show just about anything. So there are some ways to do very simple legends in an automated way, but there's also a lot of freedom to draw your legend however you want. And so that's an example of the dynamic legend.
Legends active, so that you could, for instance, click on the red. Can they be made active?
Oh, that's an interesting point. So, like, what is the activity you'd like to see when I click on the red?
See the red dots only, for instance.
I like that feature.
What Alex was asking.
Yeah. So yeah, that data filtering branch that we have in development right now, we could marry that to the dynamic legend stuff pretty nicely and have some automated data filtering.
And I guess if you could do like click control or something like that, so you could select a couple of them.
Yeah. Yeah, and I will say that as far as mouse events, the LocusZoom library does have a pretty robust set of mouse events and event hook syntax. So there are API hooks to detect control clicks, shift clicks, all kinds of stuff, mouse wheel scrolling, etc. So yeah, the tools are there. We could probably prototype that pretty quickly.
And so for interactivity, how do you bind your visual parts to your model?
Okay.
Use on VC or something, or?
Yeah. For interactivity, let's boy, how best to even approach that. Stat. Has one Z. Okay. I guess I'll start with the documentation would probably be best. So this is the documentation for the data layer stuff. Highlight and select behavior, tooltips, etc. There's a legend, labels, the interactivity. I guess it's not defined in here. It must be in panel. Oh yeah. So the interactivity for things like panning and zooming is defined at the panel level. And if I can find that, oops, layout. Okay, so to start answering that question, because that is a big question. Here we go, interaction. So we have a variety of just Boolean elements to define in the layout on a panel level. So for my genes panel or my association panel or whatever, whether I want to be able to drag the background to pan, this is Boolean, and then triggering this will cause a cascade of things down below. Likewise with some of these other things, here's that X-tick scaling and Y-tick scaling, scrolling to zoom, etc. And then there's this little X-link so that if I want my panels to scroll together, we X-link them. So that's a little purpose-built, but that's the basics. That's how you at least turn it on. Now, as for actually making it go, you know what? Let me get back to that, because we could do a deep dive into the code, and there's a lot. It took a while to get right. So
is it you using some custom implementation to do that, or using some frameworks or anything?
there is some. I mean, it's all.
What are your dependencies?
The dependencies are very limited. The dependencies are only D3, and then we also have a dependency on the Q library for promises, since promises aren't standard in JavaScript yet. And this is not ES6. This is just ES5. Yeah, standard common JavaScript. But D3 is the only major dependency, Q being the one for promises. But that's only used for getting data, of course. Yeah. So
since it's all front end, did you consider publish it as a NPM module or something, so it can be be used in the dependencies in other apps and something?
Yeah, I mean that's certainly the thought had crossed my mind. Personally, I had always sort of looked at NPM as something that was more back-end focused, but there's no reason why it couldn't be published as an NPM module. So yeah, I mean I personally haven't worked with Node that much. So are there a lot of front-end packages on NPM?
A lot. Okay. I mean everything like D3, the Megalite, and everything that I already mentioned. I think it is becoming a standard publish that, because what you can do, you can create a package JSON, which is also just a config file, and say my dependencies are this, and you don't have to include D3 anymore, because it's gonna go and look at up in NPM, and when you clone to GitHub and you run npm install, it installs all the dependencies that you have. It just pulls them from their own repositories. You just need to specify which versions you need to and stuff like that. Yeah. So we are actually in my lab, what we're building a platform for web-based visualizations for all kinds of customer user-provided data. Mm-hmm. So all kinds of visualizations, and what we do sometimes, someone makes a front-end app like this, and then they provide the hooks for data and input. What we do, we go to NPM, we just take their development, their app, as a dependency for our platform, and then after a couple of days, boom, our platform has a new type of plot with a new type of functionality, including all the things that people develop.
Definitely. So
that would be very interesting, and actually, this probably maybe could fit our purposes as well. So this is very interesting.
Great.
Yeah, and then for the, not sure how much time did you spend on this activity, but what we, from our experience, the best was using Angular.js. Mm-hmm. What allows you to do it allows you to have a data model as an object, so you have like a settings object, and then it does the two-way binding to your visual part in D3, all your SVG elements. So as soon as you change your data, it updates the SVG element, colors or whatever. And then as soon as user changes something, hits any controls, those controls update the data model, which again updates the SVG.
Yeah.
And so that was, I think, we avoided all the callback hell and all the complications when you have to listen to those things yourself.
Yeah, and we avoided a lot of that as well. I really would say there is not a lot of callback hell going on here at all, because we're leveraging D3's enter, update, exit model, so that all the data in the data layer level that is displayed, so those all those association points and everything, genes, whatever, the definition of an individual data layer is going to have that enter, exit, update based on the data that is stored on the data layer itself, which there's the whole request layer, which will update that data based on whatever region I'm looking at, or however I've defined my data sources to do that. And so all of that happens in a very, very automated way using just the sort of D3 core approach. And we really wanted to limit our number of dependencies. So we did talk early on about those broader frameworks like Angular and React, and could these help us get somewhere else? But the idea is we wanted to keep it really constrained in scope in terms of just how much external framework we really needed to leverage. And D3 seemed to present pretty much everything we needed to do it in the way that we've done it so far. So, but again, it's a moving target, and we could potentially go that route in the future. I've certainly been looking a lot at D3 version 4 to see if there's anything in there that would be interesting. But yeah, that's sort of the approach we have right now.
Yeah, but definitely if you if you publish this as NPM, I think that would be a lot of interest for other people.
Definitely. Yeah, thanks for the suggestion. We're right about 1 o'clock. I do want to show one last example of LocusZoom and how it can be a little customized to do something very different. So here, the Michigan Genomics Initiative, which some of you may have heard of, big study that happens here between a lot of folks that work here. And this is an example of LocusZoom doing what's called a GWAS plot. So GWAS is a phenome-wide association study where it's almost, you think of it as, when we're looking at any one of those GWAS plots before, we're looking at one specific phenotype. Like when we were looking at the example on the genetics portal, this GWAS is body mass index. This GWAS is type 2 diabetes. Well, there's a million phenotypes. I mean, not that many. There's a lot of phenotypes, depending on how you slice and dice them. And so here what we're looking at is a single variant. In fact, this is a variant that happens to be somewhere toward the end of the 10th chromosome. But we're looking at how the p-values for that single variant across almost 1,500, different phenotypes. So here is, this particular variant, which is in the FGFR2 gene, has a peak for different types of breast cancer. And the way MGI does it is it's sort of translating ICD-9 codes into phenotype codes so that we can have sort of a consistent list of phenotypes. But that's an example here. And we have the same gene plot down here just to show where we are. But this is all using the same exact LocusZoom library to generate a very different kind of plot, including this here. This is a different data layer that just shows, it's kind of like, this is what the bottom of a Manhattan plot would look like, where we just have all of our chromosomes. And this just tells us where we are across the entire genome. And we're somewhere on chromosome 10. And what we did here, just for this example, is we threw 5 different ones up there. But now we're looking at somewhere on chromosome 4. And we're looking at the PITX2 gene, which, yep, there's PITX2 right there. And, that one has atrial fibrillation. TCF7L2, which is what I loaded up right over here, this TCF7L2, and type 2 diabetes, there it is, there's its peak. So this is another example of something very different that can be done with LocusZoom because, again, built as a framework for rapidly prototyping data layers that tend to be based around looking at a region of a genome, but not necessarily, because as we're seeing here, we're not looking at a region of a genome. We're looking at one particular variant, and so now we've almost pivoted to a different dimension, and we're looking across all those phenotypes. So yeah, I just wanted to show you guys that. Yeah?
It's probably a really stupid question, but
No such thing as stupid.
Is there any reason why along the bottom you don't have the coloring for like the p-values and stuff with the little crossbars?
The p-values with the crossbar. Oh, so these aren't actually p-values.
It's kind of more on the other graph plot, but even on this one too, like so you could say down below, not the dots, the lines.
The ticks along here.
Nope. There you go.
The genes.
There you go.
Yeah.
Like wouldn't those have colorings for their significance?
Ah.
Have the cross
Good question. So what this panel is showing is it's just showing gene transcripts. So this is showing that the TCF7L2 gene starts here and ends here, and these little peaks are exons within the gene, so the actual protein coding regions. But other than that, there is no association data represented in here. All this object represents is this is the extent of the gene as it exists in the gene catalog, and these are where the exons are. So the coloring wouldn't really have any meaning here. There are plots out there that do color genes based on different pieces of data, but it wouldn't necessarily be association data. It would be something else, like, you know.
Could you add EQTL to this plot?
Yes, we could. And actually, there is a gentleman in our group who is really all about EQTLs, and he really wants to see them in here. So that's something that we'll probably be looking at in 2017.
That's some nice extra information for the gene layer. You can also have like that variant.
Yep.
EQTL data.
Definitely. And you know, a lot of folks have working with traditional LocusZoom have worked with interval track annotations, interval annotations, or bed annotations. That's a common thing, and that's actually another branch on the LocusZoom library that's in active development right now and will probably be released in the production version for use within probably just a few weeks. So we're really actively working on that because we know the Broad wants to pull in annotation track data, and also for our own LocusZoom website, our backend that has a lot of these data stored in a database ready to go with a web API. We have an API endpoint for annotation track data. So the LocusZoom website will also have a way of pulling in some limited annotation track data sets, really as a proof of concept. But yeah, so there's a lot of active development in a lot of areas, and we want to hear about more. So yes, EQTLs, knowing that there is demand for that, will help us prioritize that higher. Yeah.
And have you thought about linking also to UCSC? So you could just like query their API and like show a UCSC. You don't even need that on your server. It's just.
Yeah, we've talked about that one too. In fact, that one we've just started talking about in the last couple weeks. Personally, I've not worked much with UCSC, and I'm just starting to develop a concept of, what role the UCSC genome browser fills in this world, because there does seem to be a lot of overlap with the kinds of problems we're trying to solve with LocusZoom. And so, I still feel like there's enough of a difference there that they can coexist and they complement each other, I hope. But yes, we have talked about trying to tap into all of those tracks that are on Track Hub that they have with UCSC, and
then you could pull like this like nice variant and use this on a DNA sensitivity peak.
Yeah. And
then you pull that data from UCSC and then it's really cool.
Definitely.
Peak here, and then you also see a peak over there, and there's also nice variants.
Yep. Yeah, and with things like that, it's all a question of priorities. Because just to talk real quick about developer resources, while this is open source and we would love contributions from anybody who really wants to dive in, it's been pretty much my show for a while now. I did have another developer who was helping me in the beginning, but it's been pretty much just me at this point. And so I'm taking a lot of my cues on what to work on from everywhere. So folks like yourself who are saying, hey, I would like to see this and this and this. Got a lot of feedback from ASHG on what different people would like to see. But then there are the requirements laid out by the AMP consortium and the portal projects, because they actually bring the money to the table. And then there's our own internal CSG stuff where we have our LocusZoom website and what kind of things we want to see. So just trying to keep all that in concert. And but either way, development is very active, and because we've sort of built it as a framework for the rapid prototyping of visual display of things. If there's a data set, like EQTLs is a really good example of this, if there's a data set that already sort of fits this mold, and all we have to do is spin up a visualization for it, chances are it's probably pretty fast to spin that up. We just need to sit down and do it. Any other questions, anyone? All right. Well, LocusZoom.org, it's on GitHub. Please play with it. Please send me feedback if you decide to use it. I would love to hear what you think, and thank you so much.